So, my name is Gunjan Patel. I'm a cloud architect in developer relations team at Palo Alto Networks. And I've been working on containers and Kubernetes for last 4 years as a developer and architect. So while we wait for, we'll give folks another 30 seconds. That's my Twitter over there. I have some Kubernetes stickers, exclusive ones. If you tweet a cloud joke at me, first 2 people will get those stickers, and the rest of you will get panda stickers. I'm a big stickers fan, as you can see from my laptop here. Anyway, so we're going to talk about container security best practices. I have a demo that I'm going to do live. Hopefully it will work. So before I start, how many of you consider yourself beginners with containers? Okay, intermediate, advanced. Okay, all right. So I have some material that will help you understand some basics of why container security is different. And I'm hoping that you're all are familiar with VM and cloud stuff. So I'll base it off of that. So if you have heard of this thing, this is called the technology adoption curve. This shows all the technologies that start here. There is a chasm. A lot of technologies don't make it through the chasm. And then after the technology crosses the chasm, it enjoys early majority, and then eventually it dies down, right? So if you were to place the new computing technologies, serverless would fall somewhere here. Containers, it's considered that containers have crossed the chasm. And right now, virtual machines are the majority of the deployments, early majority. There are still appliances, but they're being phased out, on-prem appliances for your compute. So containers are, okay, all right, lost my pointer, sorry, are supposed to take over and become the majority. Google already spins about 4 billion containers in a week. Everything you use on Google probably starts a bunch of containers. So how did this evolve? So containers is just one technology that enables microservices. I'll try to explain the evolution, how things evolved from monolith architecture to microservices. That's the architectural pattern. Containers just enables them. So this floppy disk emoji, it stands for your software. You write some software. You have a bunch of developers working on it. Developers, DevOps, people who maintain it, right? As your software grows, you have to hire more people. And they're still working on the same monolith code. Ultimately, it catches fire. It becomes hard to manage. So microservice architecture, what it does is instead of having one big monolith application, you break it down into a bunch of tiny services called microservices. And each team manages that small piece of software. And these microservices can be in any language. The only requirement, well, 2 things. One thing is if you can feed a team with two pies of pizza, that's a microservice team. A team shouldn't be bigger than that. And these microservices talk to each other through REST APIs, gRPC, some sort of standard interface. So with microservices and containers, what used to be like this, you send a request, was served by one virtual machine or one physical server, it became this. Same request goes, and now it bounces across multiple containers, multiple microservices. So that So as things move from virtual machine monolith and physical infrastructure to more agile containers, more dynamic workloads, this is kind of the main difference. Containers are a lot smaller. The main thing that's different is they share the host OS, they share the kernel. Sometimes they can also share the libraries. Those are layers in container, and read-only layers are reusable between different containers. So they are much smaller, and they work across different operating systems. So that made the problem of managing things harder. You would think that things moved from, you used to manage hundreds of servers or thousands of VMs, and now it's millions of containers. And containers, on average, their life cycle is in seconds, less than 5 seconds. So they're highly dynamic, and there's lots of them. I want to quickly explain what goes into a container, what's in a container image. So this is a container image that your developer or you are writing, right? These are a bunch of layers. Every container image has a bunch of layers. So let's blow it up and look at each layer. So this is a typical container image. Not all images are like this. Your base layer, the very first layer in the image, is typically your operating system flavor that you want to use. Remember, it shares the kernel, but you can still have an operating system flavor as the base OS. Then you typically have, if you have non-compiled languages, then you have your language runtime and other runtime dependencies. And then after that, the layer above that is third-party libraries, your core dependencies, your NPM packages, Maven, stuff you're importing. This is a cool acronym. It's OPC. Does anyone know what OPC stands for? Oh, you're close. Other people's code. Because as a developer, developers don't want to write all the code, right? They only focus on what's critical to their application. If I want to do something, someone already somewhere has written a library for that. So I'll import that. I don't know who wrote it, but I will import that and use it. And the last layer, the top layer, is your code, your configuration. This is where your developer puts their code, right? Now, you don't know who wrote these 3 layers, which is like in a container image, which is the 99% of the image, right? 95 to 99% of the image. So just keep this in mind when I talk you through the security best practices. Quickly, life cycle of a container. If you're not familiar, there's a Docker file, which is a manifest on how container is built. It specifies what goes into this container image. When you do a Docker build, you get a container image, which is read-only and has these layers that I talked about in the previous slide. And when you do Docker run, you get running instance of that image, which is a bunch of containers. So containers are running instance of an image. And containers are read-write, images are read-only. Now we can focus on securing containers and your container infrastructure. So the way I look at it is there are 3 very high-level areas to focus on for container security: securing the code pipeline, securing the runtime, and securing the environment. I'll talk about some specific recommendations. I will not have a specific project recommendations on how to do things. That will be a longer talk. I'll tell you what to do, and we'll see a reference implementation. So what I mean by code pipeline is securing the whole thing when it moves from code. Your developer writing the code goes into CI/CD automated pipeline. before it makes it into production. And runtime, when your container environment is running, when the container is actually running, wherever they are running. And the third thing is environment, where they're running, cloud, or it could be on-prem, securing that environment, because not everything is containerized, right? You're still running this on virtual machine. You're still running containers on VMs or on actual physical hosts. So for securing the dev pipeline, the development cycle has changed. It's not exactly what it used to be. The process used to be like this. Your developer, this is in blue stuff is what developers doing, and orange is what security and ops teams are doing. This is the time axis. Developer hides in a corner, writes some code, does the packaging, has RPM packages or something. At the same time, your security and ops team, they're designing the infrastructure, provisioning hosts, configuring, securing things. Oops. Oh, how did that happen? There's a button here that I didn't know about. OK. So, and when it's production day, not exactly production day, but like weeks before production, they meet for the first time, and then they deploy it, and then they're wondering how it got hacked. So this is the cycle. Now what happens is everything is written as code. So your developer writes the code. Now your image, which has the base operating system, you're specifying the operating system while you're developing the code. All the libraries, runtime, your developer's even writing the Kubernetes manifest on how your application is going to be deployed. So this phase, when they're doing the packaging, either container image packaging or crafting the Kubernetes manifest, this is where security and ops teams should work with them. You should have a bunch of allowed images that you're only allowed to use these IT-approved images or these packages, and some best practice. We'll see. I'll show you a demo on how to do this. And then you deploy, so it's much smoother. So by the way, this thing, doing things, security-related things early in the pipeline is also, you might have heard the term called shift left. Shift left is finding things early in the cycle, early in the development cycle, so it's much cheaper to fix things. The recommendation is not just shift left, but shift left and right. Shift left, the example I like to use is having doors in the house. If you have doors and you lock the doors, you're preventing things from coming in, but you don't know what's happening inside the house. So having cameras is kind of like runtime security, which is shift right. So you kind of need them both. How many of you are Game of Thrones fan or watch Game of Thrones? You heard the keynote. Nikesh mentioned Game of Thrones, so I'm safe to mention Game of Thrones now. So Sir Davos mentioned safety is never a permanent state of affair, which is true for security, right? Security is not a one-time thing that you do early in the cycle or something, and then you forget. You have to continuously make sure that your environment is safe. So this is one reference architecture on securing your container infrastructure. How many of you heard about the Prisma public cloud announcement last week? So we announced 2 free public APIs that you can use for one, infrastructure as code scanning, which can scan your Kubernetes manifest, Terraform, CFT, all those infrastructure as code pieces for security best practices. If you're missing any, if there's any policy violations, it will flag them, give you the exact policy violations. And the second one is image scanning vulnerabilities. You have container image, you have a bunch of packages there. It will give you all the vulnerabilities associated with all the packages in this container image. So in this reference implementation, what we're doing is we're embedding those checks in the CI/CD pipeline. So your developer writes some code, but your security team works with DevOps, or security team works with them to add these checks in the CI/CD pipeline. That means if it doesn't meet your requirements, it doesn't go through the CI pipeline. So what we're doing here is you have Kubernetes manifest. Kubernetes manifest is how you're deploying your application configuration. You send that here, ISC scanning engine. You get the verdict back. If that looks good, moves on to the next one. You have your container image. You send the list of all the packages to this, and you have some policy. For example, do not allow more than 0 critical or high severity vulnerabilities in this container image, or more than 5 medium severity vulnerabilities, or disallowed packages. You stop developers from using certain packages that you think are vulnerable. So if it passes both of them, typically it goes into version control system, GitHub or Bitbucket, whatever you're using. Remember, everything is stored as code. Your code file, Kubernetes manifest, Docker file. And after all this is successful, that's also the image you build. It goes into the container registry where you store all your container images. And when it's deployed in production, so all this stuff this line is pre-deployment. You iterate over this, and you deploy the final version that's tested and looks good. When it's deployed, you want to do traffic security, east, west, north, south, container to container traffic, and container to the world, and world to the container. You can do that using VM series. This also happens to be the lab topology for one of the labs I'm doing. If you're interested, I'll be doing one last session right after this presentation, if you want to do this hands-on. OK, so Kubernetes itself has a lot of security concepts. There's a lot of things built into it for security. I just want to mention a couple of those. So we'll talk about some of the low-hanging fruits that you should do for your Kubernetes security. So the first one is least privilege, using least privilege, OS hardening, and logging. I'll talk about specific examples of these. Next one is image scanning. Scan your images. You know what's going into your environment. So you know what's going into your environment. Network policies, RBAC, some of the constructs provided to you by Kubernetes. And some of the advanced concepts, not so low-hanging fruits, but pod security policy using SELinux, seccomp, avoiding kernel exploit and container escapes, and application layer policy using service mesh technology like Istio. OK, so now I will talk about the recommendations on what you should look for when you're for securing your container infrastructure. So at a high level, there are 7 areas that you need to pay attention to. Kind of like, how many of you do meditation or yoga? OK, one person. I don't do it myself either. But so in meditation, there are 7 chakras. I don't know, that you have to open. Somehow adds up to the number of recommendations I have. But then later I realized there's OSI also has 7 layers. So I could have used that. It's very confusing. So let's go and look at some specific what to do and what not to do. So first one is securing the build pipeline. These are the 5 recommendations. Verify the image source. Always, there are several projects that you can use to verify that this image you're pulling in is actually, in fact, coming from this repository. Next one is scanning your images for CVEs. We already talked about that. Scanning your configuration files for security and compliance checks. So this config file, this is where Prisma Cloud IAC scan comes into picture. Static analysis of the code and dependencies. There are several projects for doing this. You actually check your code against, memory escapes and things like that. Limit the number of allowed base images so your developers don't go crazy and use any random base new Linux distro that they hear about on Reddit. Next one is securing the network. So this one, hopefully you all are more familiar with. What is different about containers is there's a lot of traffic. Now there's traffic that doesn't leave the host. If it's container to container traffic, stays on the host. It depends how you have configured it, but for most cases, if it's the same host, if two containers end up on the same host, they're talking to each other, doesn't leave the host. So these are some specific recommendations. One, firewall the traffic that's going out of your cluster and coming in. By the way, how many of you have heard of, I'm not supposed to mention the company name, but there's a very famous electric car maker based out of California. A car I would really like to have, but I can't afford one. Their Kubernetes cluster was hacked. I think last year. That was one of the first famous Kubernetes security attacks, and the company that found that thing was Redlock, which is now part of Palo Alto Networks. That was because their Kubernetes dashboard was open to the internet. It was as simple as that. So hackers got in. They were doing a bunch of crypto mining. They got access to the AWS keys, and they were very clever. Anyway, we'll talk about that later. The next recommendation is locking down layer 3 or 4 using network policy. Network policy is something Kubernetes has APIs for that. Doesn't provide a default implementation. There are several to choose from. Creating granular layer 7 policies using service mesh. This is some new stuff. So how many of you have heard of Istio? Service mesh? Okay. So if you haven't, look it up. It's pretty cool. It goes kind of hand in hand with containers for networking. You can create granular policies that say this application is only allowed to make GET HTTP call on this other service, regardless of the IP address. Or you can have a granular policy that says, you can also do it for different protocols. But you can also specify things like all the Android user, that information HTTP layer, header layer 7. So you can also create granular policies for that. Using mutual TLS, MTLS for container-to-container traffic, so that connection is encrypted. Logging all the unsuccessful connection attempts to your services. Next one is securing the host. Securing the host is where your container infrastructure is running. So things like locking down the OS. So your containers cannot read and write. Either they shouldn't be able to write to the host for sure. Read, they can read should be fine. There is also, in containers, you can mount a host volume. So the data is shared. Even after container dies, that volume is there. So that you have to control. You have to control that. So if you have a volume that's mounted, make sure there's a specific directory that no other containers have access to. Using seccomp to restrict host syscall access, containers can make system calls. As I mentioned earlier, the kernel is shared between all the containers. It uses the host kernel. So to do all the network calls, data storage, encryption, those things are syscalls. You don't want them to go wild and make any system calls they want. So you can restrict that using something called seccomp. And SELinux is another isolation technology. You can isolate containers further and container to host isolation using SELinux. Next one is securing the container runtime. Container runtime is, Docker is a container runtime. Kubernetes is an orchestrator that orchestrates Docker runtime to, orchestrate containers. So when I say secure the container runtime, I'm talking about that, Docker runtime. So one thing that is reviewing the default security policy. All the runtimes, there's one container runtime on each host, right? There's Docker daemon running on each host. It has some security configuration, default ones. Make sure to review them, and they're uniform across all your hosts. So that's the second point. Your policy is uniform across all the hosts in the cluster. You can also restrict privileged containers. Privileged containers have access to everything on the host. It's kind of like running root on the host. You can also block that from container runtime itself. And you should also restrict access to the container runtime itself. Otherwise, if someone's running a privileged container, they can modify and attack the container runtime itself to get access to all the other containers on this host. Next one is securing the orchestrator configuration. Orchestrator, by orchestrator, now we all clearly know that Kubernetes has won that battle. So Kubernetes is the main focus, but these points can be applied to any orchestrator. Make sure that cluster level policies go through some sort of review and approval process. So there are some so Kubernetes has a lot of security policies, a lot of things provided to you by Kubernetes for security. Cluster admins shouldn't be able to make those changes without a review and approval process. They need to involve your security team in the approval process. Anything that impacts the entire cluster level policy has to go through that review process. You should also secure the orchestrator APIs themselves. So if you're using Kubernetes, not everyone has access to the APIs. And if they do, you should create granular policies on what they can do. Kubernetes has a thing called RBAC, role-based access control. You can specify which user can do what kind of operations on what objects. So in Kubernetes ecosystem, there's a lot of third-party tools, a lot of CNIs, a lot of container runtimes. You need to make sure that what you're using is you trust them. Don't use anything cool you hear about on the internet. RBAC to limit API access, as I mentioned, but also this also applies to third-party apps. Enable and log all the API requests. So Kubernetes has a thing called audit logs. Everything that changes, every API call that's made to the Kubernetes control plane can be logged, but you need to enable this. It's not enabled by default. And then scan, as I mentioned multiple times, whatever you're deploying in the using the orchestrator, scan it before you deploy it. Next one is securing the data. So This is more focused on securing the actual data, using a proper file system encryption for storing the data, providing write and exec access to only certain containers. Most containers shouldn't have write and exec access to the host file system. Scan images for sensitive data. Now, this is not scanning for vulnerabilities, scanning for sensitive data, like if you check in some API keys secret by mistake. Limit access to storage-related syscalls using seccomp. So not all the containers need storage. If they're stateless, they don't need storage access, then block all those syscalls to avoid runtime privilege escalation. And log all the attempts to access to sensitive data. Again, similar to network, but this also applies to data. The last one is securing the cloud, the environment where your containers are running. Understand the default security configuration, what AWS, Azure, Google has for the security environment. This applies to orchestrator, container runtimes, operating systems, CNIs. If you're using hosted Kubernetes, a lot of this security configuration, there's default, but you need to understand what the default is. Their default might not be applicable to you. Next one is beware of the version of the orchestrator you're using in the cloud. Hosted Kubernetes providers, they will have different Kubernetes version. Some cloud providers are faster than the other. But make sure you understand, read the release notes for that version of Kubernetes you're using, or the version of Docker you're using, version of operating system you're using. Make sure what's deployed in the cloud by default is okay with you. And also the third one is scanning the environment, environment setup, tools like Terraform, CFD, ARM. Now we have free APIs, so there's no excuse for not doing that. For security best practices and compliance misalignment in the CI, so you find that earlier in the process. Last one I was going to say, 8th layer. Does anyone know what a lot of people say OSI has an 8th layer. Does anyone know what the 8th layer is? Management. Politics. So here, 8th layer I'm talking about is people, training the people. You need to explain, your people need to understand what they're doing with containers. Containers are new. Make sure you spend some time understanding this environment and the security best practices before you actually do stuff. Running a little bit short on time, so I'm going to go faster. Almost over. So there was a quote, security should not be an afterthought. I don't know who said that, but someone smart. In conclusion, these are the areas that I talked about, 7 areas that you need to secure your container environment. Now, before I jump onto the demo, I want to explain the code to production pipeline in a containerized world. So what happens is your developer has code checked into GitHub Bitbucket. She pulls in the code. Main.go is the actual code file. Deployment.yaml is the Kubernetes manifest on how the entire application is going to be deployed. And Docker file has packaging instructions on how this container image is going to be built. Your developer modifies that code, turns orange. Remember, all of this is local on your developer's laptop. Does it compile? If it's a compiled language, you get a binary. Docker file can pull in that binary. Do a build, you get an image, local image, container image. When you do a run, you get a bunch of containers or one container. So your developer thinks everything looks fine in my environment, so I'm going to create a pull request to submit those changes back to the master code branch. When you submit a pull request, it kicks off a CI build. Jenkins is one of the most famous CI tools. This is a typical pipeline. This is what it looks like. It checks in the code that you checked in with the new changes and manifest, runs a bunch of unit tests. After those unit tests pass, you typically build the container image. When you build the container image, this is the security step. Also scan the image for vulnerabilities. And if this is where it fails, then stop the build right there. So the developer can fix it before it's merged into master. Then you do integration tests, system tests to make sure that it works with all the other applications in your environment. This is where you do where you scan your application manifest, Kubernetes manifest. Optionally, you can also have a continuous deployment. If everything looks good, then deploy it to a staging cluster. This is more often than not. After this happens, you push that container image that you created to your container registry. GCR is one of the examples. Then your QA engineer can pull in that image locally and run. And since it's a QA engineer, they'll figure out a way to break it. But they didn't just break it. They found a bug. So they create a Jira ticket, goes back to the developer. So this is the whole full cycle. All right. So if you understood that, I have a quick demo that I'm going to attempt to do live. Okay. So I have this code here. This is my IDE, Visual Studio Code. This app has a bunch of excuses. I'm calling this application Good Morning. When I wake up, I don't want to go to work. I make an excuse. This generates a bunch of random excuses for not going to work. So I'm going to add a new excuse. So what it does is when I run it, it says, "Hi, Ivan." Ivan is my boss's name. I need to work from home today because, and I will pick a random reason, send an email. So as a developer, I save this and go back here. Whoops, that's what happened. Oh man. Yeah, of course, it had to happen for a live demo. Any idea why this is not working? I had the coolest demo. And my boss is going to watch a recording of this session, and I might be looking for a job. Do we have anyone from AV here who can help? I thought it ends at 11. Yeah, let me try that. Anyway, I'll just talk my demo. I had a rickroll. We heard of that rickroll, right? In the terminal. Let's see. I'll just show it to you on my laptop here. Rickroll in the terminal. So what happens is I have an IDE plugin. Whenever your developer saves the Docker file, it will scan it and tell you all the things that are wrong in the Docker file, all the security vulnerabilities you have. And next thing is when you have manifest, whenever you hit save, it will scan it right there. And it will give you all the policy violations you have. Yeah, this thing turned off for some reason.
Did your Mac go to sleep?
No. And the second thing I had for the demo is I have an integration with Circle CI, where whenever I make a change in my Docker file and manifest, I check in the code. The same thing I showed you in the slide before that one. It runs through those things. It will do security. There are 3 steps for security: scanning the container image, and if it has certain packages that are not allowed, certain CVEs, and more than 1 or more than 0 critical and high CVEs, it will fail the build. Developer goes back, fixes it. I was supposed to be the developer. Go back and fix it. PR runs again. Everything goes fine, and it will publish the image to Docker Hub, which is the image repository. Can you try it on this side, maybe? But yeah, that was the demo. And I actually have a GitHub repository where you can go, and I have all these recommendations in much more detail. I also have created a lab guide for you guys, so you guys can go through those tutorials on your own, on your machine, and how to use this IDE plugin. I have some configuration for you. Since I don't have the links here, I'll just say github.com/gunjan5, my name, GUNJAN number 5 /container-security. That's where you'll find the slides for this lab guide that you can follow and detailed instructions on securing your container infrastructure. All right. With that, I'll end the session.